Hello, my dear students and my dear friends. I welcome to my YouTube channel. Already in the Fourier transforms, I finished part 3, part 2 video lectures finished. Now we want to discuss about part 3 video lecture of this Fourier transforms under heading of Fourier transforms, which is B.Sc, which is under B.Sc complete guide course, which is under B.D. Sorry, under B.Sc complete guide course, under B.Sc complete guide course. So, my dear friends and my dear students, if you not subscribe my YouTube channel, please subscribe my YouTube channel as Tirunagaram Manohar, and like this video and share to your friends, as well as without forgetting you should write your comment on my comment box. Thank you. Now in this under heading of Fourier transforms, we are discussing about part 3 right now. So on this first one, problem sum Fourier integrals. For problem sum Fourier integral, in previous video lectures already 4 problems are completed. Now 5 problem, which one is very important for 5 marks. This is very important for 5 marks question of your B.Sc exams. So these 5 marks questions here, using Fourier integral method for a greater than 0 and b greater than 0, show that e power ax minus e power minus ax minus e power minus bx is equal to 2 times of b square minus a square divided by pi into integral u is equal to 0 to pi into u sine ux by u square plus a square into u square plus b square into du. This is the question. So now we want to discuss about this answer. So by the, what do you want here? Integral of sine function we want. So that's why we should take the sine form of Fourier integral. So by the sine form of Fourier integral, we have f of x is equal to 2 by pi into integral u is equal to 0 to infinity, integral t is equal to 0 to infinity, f of t into sine ut into sine ux into dt into du is the sine form of Fourier integral. So here f of x is equal to is what? Here in this problem, f of x is equal to this left side part, that is, so that's why e power minus ax minus e power minus bx is equal to, in this formula, 2 by pi, which is equal to integral 0 to infinity, and integral t is equal to 0 to infinity, right, as it is. Here f of t is equal to what? Instead of x, t will come e power minus at minus e power minus d minus bt into e power ut into sine ux into dt into du, where we write as it is. Next, 2 by pi, right, as it is, integral 0 to infinity sum. Now I am writing u terms at one place, du term, that is sine u into du, including integral. Now remaining integral t is equal to 0 to infinity e power minus at minus e power minus e bt into sine ut into dt. Call it as equation 1. Call it as this one, equation 1. Now separately we want to find this one value, this for second this term value. Again, by substituting that term value, we will get the answer. See here, we know the formula. Integral t is equal to 0 to infinity e power minus at minus e power minus bt into sine ut dt is equal to This one, integral t is equal to 0 to infinity, we are splitting this term for the both these two terms, for the both this term, e power minus at into sine ut dt minus integral t is equal to 0 to infinity e power minus bt into sine ut dt. You all know this one. Integral 0 to infinity e power minus at sine ut dt value u by a square plus u square. This one value u by b square plus u square value. How it will come means, see here, I am explaining here this value. Here, see this one clearly. We know this formula. Integral e power ax into sine bx dx, integral e power ax into sine bx dx is equal to e power ax by a square plus b square into a sine bx minus b sine bx formula. So in this formula we have to apply that function. This first function we are applying, this first function. So that's why integral u is equal to 0 to infinity e power minus at into sine ut into dt, which is equal to integral e power ax e power minus at by a square plus u square into, instead of a value is what, minus a is there, minus a into sine b in the b place, which is that b place is ut minus b means this one, b means u into cos ut, cos bx means cos bt, ut. So interval from where to where, this one changing from 0 to infinity, 0 to infinity, that value. So by applying that limit value, we have to see here e upper limit we want to apply here, e power minus a into infinity by a square plus u square into minus a into sine, in the place of t we want to replace, so minus a into sine of u infinity minus u into cos of u into infinity, again lower limit minus e power minus a into 0 by a square plus u square into minus a into sine u into 0 minus u into cos u into 0. So this is the applying the limits value. See here, e power minus infinity, e power minus infinity value 0. Okay, 0 by this value into this value, into that value, minus e power 0 value 1, e power minus 0 or e power 0 1 divided by a square plus a square into sine 0 0, so that's why minus a into 0 minus u into cos 0 value 1. So that's why this total term becomes 0. Again this one value minus a into 0 0, this one minus into minus plus u by a square plus b square. Like this way we got this one u by a square plus u square. Similarly this one also u square by b square plus u square. So that's why this equation becomes next step. See here, this u by a square plus u square minus u by b square plus u square. Got it? No? So by simplifying this term, LCM a square plus u square into b square plus a square. So that's why by the cross multiplying u into this one. So that's why u into b square plus u into u square, u cube, again minus u into a square minus a square, minus into plus minus u into u square, u cube. See here plus u cube minus u cube get cancelled. Remaining in this term and in this term u is there. So that's why u take common. So remaining here b minus b square minus a square by this term, right, as it is. So hence equation 1 becomes this equation. Here this equation becomes this value, you find it right now. So by substituting that value here, this becomes, see here, this becomes how you change from right left side. What is that? E power minus ax minus e power minus bx is there, which is equal to 2 by pi into first term, right, as it is. Integral 0 to infinity sine ux into dx is there. Next, this one value here, second term value, write as it is. V square minus a square into u by a square plus u square into v square plus u square. Again, this one, this 2 into this one, I am writing 1 plus 2 into v square minus u square by pi into integral u is equal to 0 to infinity. Already u is there, u into sine ux by a square plus u square into v square plus u square into du, which is the final answer of this problem. So see here, you got it, this answer. If it is clear, I will move on to the next question. That is sixth question. Sixth question, which one also very important. This one also very important for 5 marks question. For 5 marks. Show that e power minus x into cos x, which is equal to 2 by pi into integral 0 to infinity u square plus 2 into cos ux by u to the power of 4 plus 4 into du. This is the question. We want to prove this one. We want to show. So here cos functions are involving. So that's why we want to use Fourier cosine integral formula. So that's why that is Fourier cosine integral formula. F of x is equal to 2 by pi into integral 0 to pi into integral t is equal to 0 to pi f of t into cos ut into sin ux into du into dt. So in sine Fourier integral form means both sine will come. Here cosine integral formula means both here cos will come. Observe carefully where x lies between where x lies between minus infinity and plus infinity. Here by taking f of x is equal to e power minus x into cos x. E power minus x into cos x term we are taking f of x, which is here x greater than 0. So that's why e power minus x into cos x is equal to 2 by pi into integral 0 to infinity integral t is equal to 0 to infinity, this one function value e power minus t cos t into, in this formula we are applying f of t means what, this one e power minus t into cos t. Next cos ut write as it is, sin ux write as it is. Next we are splitting this both the integrations. So here 2 take into inside. So that's why 1 by pi into integral u is equal to 0 to infinity cos ux into dx. Cos ux into du here. Du into integral t is equal to 0 to infinity e power minus t into 2 cos ut into cos t into dt. So this one 2 into cos ut into cos u cos t, these two terms into dt. See here 1 by pi write as it is, this first term write as it is, next term here u. So integral 0 t is equal to 0 to minus infinity into e power minus t into this one formula we want to apply, 2 cos c into cos d formula. So cos of c plus d into plus cos of c minus d formula. 2 cos c into cos d is equal to cos of c plus d into plus c plus d plus c minus d for this one. So that's why here c is nothing but what? This one, c. this one d. So that's why cos c plus d ut plus t. So that means by taking t as common, u plus 1 plus here u minus 1 into t into dt will come. Next, we all know that e power this function value integral 0 to infinity e power minus x into cos x into dx value 1 by a square 1 by 1 plus a square. This value how will come means in this formula we want to apply here. Okay. Next, this one becomes, therefore this one becomes, how it comes here, e power minus x into cos x is equal to 1 by pi into, in this step we are seeing in this step. So 1 by pi into integral 0 to pi cos ux into dx into this function ux into this one, integral 0 to minus infinity into this value cos of u plus 1 into t dt plus cos of e power minus t into cos of u minus 1 into t into dt value, like this way that will come. So this becomes 1 by pi into this first term we are writing as it is. Second term, see here, this one value becomes 1 by 1 plus 1 plus u plus 1 whole square. Formula already derived like this in the first step, only derived in the previous problem. Integral e power minus ax into cos bx formula, we all know that. So this is nothing but a square by a square plus b square. But here a value how much? 1. Here a value 1. Next b value 1. B value also 1. So that's why here apply it 1 square by 1 plus b square. 1 plus b square. B value 1. A value 1. A value 1. B is equal to A. B is equal to A. Now coming to this one. See here. This one. This value becomes 1 by 1 plus u plus 1 whole square plus 1 by 1 plus u minus 1 whole square. So 1 by pi right is integral 0 to infinity. This one cos I am taking here last. Next by simplification this one. So here 1 plus u minus 1 whole square form. So that's why 1 plus u minus 1 whole square u square plus 1 square minus 2u plus this one 1 plus u square plus 1 plus 2u. Here plus 2 minus 2u get cancelled into du into dx. Here 1 by pi into integral 0 to infinity into here 1 plus positive values here u square value u square plus u square 2u square 2 common ತಗೊಳ್ಳಿ 1 plus 1 plus 1 plus 1 ಎಷ್ಟಾಯಿತು 4. So already 2 take common taking, so that's why again 4 will come. So 2 times of u square plus 2 will come. This denominator expand it. So u square plus 2u plus 2. Similarly this one expanding this one. So into cos ux into du right as it is. Here 2 take it outside 2 by pi into integral 0 to infinity u square plus 2 by this one. This value becomes u square plus 4 into ux. So we are writing as it is. This value how will it come? Yes, see here. That denominator here is there. See here by multiplying it first term to this all 3. Next first term to like this. Same second term to these 3 terms. We are multiplying, simplifying this one. So what will come? U to the power of 4 plus 4 will come. So that's all here. U to the power of 4 plus 4. This one is the answer. This one is the one of the important question. Now, if it is clear, I will move on to the next question. See here, express f of x is equal to 1 for x lies between 0 and 1. The f of x is equal to 0 for x greater than 5 as a Fourier sine integral. And hence evaluate integral 0 to infinity 1 minus cos pi u by u into sine ux into dx. See here, very beautiful question. We have Fourier sine integral sine form of f of x is equal to 2 by pi into integral 0 to infinity f of t into sine ut into sine ux into dt into du value. See here, but we know that f of t value 1 for x lies between 0 and 1. So that's why here f of x value is how much? This value 1. This value 1 into this function sin ut into sin vx. Sin ut into sin vx into dt into du. Now 2 by pi, right, is integral 0 to pi now integral 0 to pi sine of ut into dt. So what will come? Integral 0 to pi means, see here we are applying cos value. So integral sine ut means what? Minus cos ut by u. Intervals 0 to pi. So this term we are writing here as it is. Next 2 by pi, right, is integral 0 to infinity minus cos ut plus ut here by applying upper limit minus cos u pi, that is upper limit, by applying lower limit also minus into minus, so that is equal to plus cos u into 0 0 by u into sin ux into du, right, as it is. 2 by pi into integral 0 to pi, this one cos u value, cos u into 0 value cos 0, that is equal to 1 ಅಂತ ಸರ್ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ. ನೆಕ್ಸ್ಟ್ here minus cos 4 pi value, minus cos u pi means minus cos pi u into sin ux into dx, sin ux into du. See here, now given question, here f of x is equal to this one is there. Now we want to subject this term, so that's why this term taken to that side. Integral u is equal to 0 to infinity 1 minus cos pi u by u into this one sin ux into du. So this one keep it is from here to here. Remaining 2 by pi taken to that side, pi by 2 into f of x is there. So at x is equal to pi, this which will happen, which is a point of discontinuity at x is equal to pi if this of this function of f of x. So that's why the value of the above integral is becomes, so here left side right as it is, integral 0 to infinity 1 minus cos pi u by 4, right, as it is sin ux into du, right, as it is. Next this one according to this formula pi by 2 into this function we are applying. Here f of 1 method is there, f of u minus theta plus u plus theta formula is there, divided by 2. So we all know that pi minus theta, pi minus 0 value, so pi minus 0 value. How much is there? See here in this problem, pi minus is there, and between 0 and pi that will become 0, and x greater than pi means greater than value, that function value 0. See here, for that purpose we are reading here. See, f of pi minus 0 means that value becomes 1. F of pi plus 0, that means x value kanta jasti. So that's why f of pi plus 0 is equal to 0 divided by 0. So that's why in the numerator pi into 1 will come. So pi divided by 2 into 2, 4. Pi by 4 will come. So, my dear friends, I will stop my video lecture here. So, hello, my dear friends. If you not subscribe my YouTube channel, please subscribe my YouTube channel and like this video and share to your friends. As well as don't forget while writing the your comment on my comment box. So, thank you very much. Thank you, one and all.